Hello everyone, I am F.Y.B.Sc from Department of Statistics, RBNB College, Srinagar. Today we will learn the topic skewness. Skewness is the lack of symmetry. So before that, let us see what is the symmetric distribution or what is symmetry. A frequency distribution is said to be symmetric about point A if it divides the data in exactly two parts. So here we can see that these are the mirror images of each other. So this point A divides the data in two equal parts. So we can say that the data is symmetric about this point A. So there are some properties of symmetric distribution. First is here mean equals to median equals to mode. Means mean, mode, median coincides at the point of symmetry for unimodal distribution. Second is the quartiles are equispaced from center. Means the difference between Q3 and Q2 is same as the difference between Q2 and Q1. So here we know that at the center there is a Q2 which is median. So Q3 and Q1 are equispaced from the center. So this is the next property. Also one more property is there. The odd ordered central moments, so mu r when r equal to 1, 3, 5. So these are the odd order. So odd order central moments for a symmetric distribution are 0. Let us see one example. Suppose the frequency distribution is like this. So these are the classes 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. And suppose the frequencies are given as this is. So here we can see that the first and last frequency are same. Also the second frequency and second last frequency is same. So in this case the distribution is symmetric. Also there are some examples for symmetric distribution, like if we plot the frequency curve for intelligent quotient, then it is symmetric distribution. So this third property, that is odd order central moments are 0, can be proved. So we know that for a symmetric distribution it is equispaced, so quartiles are equispaced and the frequencies are also equispaced. So the deviation xi minus x bar are equal but opposite in sign. So they are equal in magnitude but opposite in sign. So the odd order fi into xi minus x bar bracket raised to r. So these odd order moments are positive if xi are greater than x bar, and they are negative if xi's are less than the center x bar. So in this way, if we take the summation of fi into xi minus x bar bracket raised to r and summation of fi into xi minus x bar bracket raised to r, so here xi are less than x bar and xi are greater than x bar. So these are the odd, suppose odd power, then if we add these two, then we will get it as a 0. So addition of these two frequencies gives us mu r for odd ordered central moments. Means the value of r is either 1, 3, 5 and so on. So if we add or sum of these two values, then we have equals to 0. So this is the property. for symmetric distribution only. So let us see now the concept of skewness. So skewness is lack of symmetry. Lack of symmetry means the curve is either elongated to right side or the curve is elongated to left side. So in this way we can plot the two type of curves which are not symmetric. Here the curve is elongated towards the right side, so it is called positive skewness or positively skewed distribution. While if the curve is elongated towards the left side, then we call this distribution as negatively skewed distribution, or the curve is of negatively skewed distribution, or there is a negative skewness. So these are the two types. We can see some examples. So for here positively skewed distribution, the example is if we plot the curve of annual income, then it will be of this type, and if we plot the curve of the deaths in adults, then it will be of negatively skewness or this type. So there are some measures to measure this skewness. So these are the coefficient of skewness. So it is first given by Karl Pearson. So let us see the Karl Pearson's coefficient of skewness. So we know that this is the symmetric distribution, and here mean, mode, median are coincide. This is positively skewed distribution where mode is less than the arithmetic mean. So at the center median will lie. So in this way mode will be less than arithmetic mean, means the difference of arithmetic mean minus mode will be positive in case of positively skewed distribution. Similarly, this difference is negative for negatively skewed distribution. So here we can see that mode is greater for negatively skewed distribution. So difference between mode and arithmetic mean is less than 0 or greater than 0. So Karl Pearson has used this concept, and he has given the coefficient of skewness as Sk equals to this arithmetic mean minus mode divided by Sd. And if Sk is greater than 0, then we say that the distribution is positively skewed. If Sk is negative, then we say that distribution is negatively skewed. If Sk equals to 0, then distribution is said to be symmetric. This Sk is a pure unitless number. Also, it is independent of change of origin and change of scale. In some cases, mode cannot be obtained. So, in that case, the formula for calculating Sk is Sk equals to 3 times x bar minus median divided by Sd. Sd means the standard deviation, we denote it by sigma. So in that case this formula is used. So basically the value of Sk lies between -1 to 1, but there is no limit of no limit of the value of Sk. So theoretically it lies between -1 to 1, but rarely it lies between -3 to 3 also. So to compute the Sk or Karl Pearson coefficient of skewness, we require the quantitative data only. But if we have the qualitative data, means data of attribute, then this formula cannot be used, and in that case we use the next measure of skewness, which is Bowles's coefficient of skewness. So, as we know the property of symmetric distribution, that the quartiles are equispaced from center or from Q2. The distance between Q3 and Q2 is same as Q2 and Q1. If this Q3 minus Q2 is greater than Q2 minus Q1, so this will happen in case of this So this difference is larger than Q2 minus Q1 in case of positively skewed distribution, and Q3 minus Q2 will be less than Q2 minus Q1 in case of negatively skewed distribution, because the curve is elongated towards one side. So here will be Q1, and this difference is little bit larger than the difference between Q3 and Q2. So this concept is used while calculating Bowles's coefficient of skewness. So the relative measure of skewness is given by SB equals to Q3 minus Q2 minus Q2 minus Q1 divided by Q3 minus Q2 plus Q2 minus Q1, or we can write this as Q3 minus twice Q2 plus Q1 divided by Q3 minus Q1. So this is the relative measure of skewness given by the scientist Bowles. So this SB will lie between -1 and 1. So let us prove this. The statement is SB means Bowles's coefficient of skewness lies between -1 and 1. For that purpose, let us consider this Q3 minus Q2 difference as B and Q2 minus Q1 as A. So SB will be B minus A upon B plus A. We know that A and B are positive. So we can write B minus A will always be less than B plus A. Mathematically it is proved. So now B minus A divided by this B plus A should be less than or equal to 1. So this implies SB is less or equal to 1. Here we have proved. So SB is less or equal to 1. Now to prove the remaining part, we know that A and B are positive, then minus B must be less than plus B. So let us subtract a constant from both sides. We have this. Further we can solve this as, and if we take this B plus A to this side, then we have this quantity must be greater than equal to -1, means -1 is less or equal to SB. So from these two brackets we can say that the SB means relative measure of coefficient of skewness SB lies between -1 and 1. Now let us see the next coefficient measure of coefficient of skewness, so which is Pearsonian's coefficient of skewness. So from the property of symmetric distribution, we know that the odd order central moments are 0 for symmetric distribution. So the odd order moments can be used to measure this coefficient of skewness. But we know that mu1 means first central moment is always 0. So the next odd order moment, which is mu3, and mu3 is used to measure the coefficient of skewness, and the Pearsonian's coefficient of skewness is given by gamma 1. So it is the root of beta 1. It is relative measure of coefficient of skewness, where beta 1 is mu 3 square upon mu 2 cube. So this quantity will be always positive. So as this quantity is positive, we cannot say the nature of frequency distribution from beta 1. For that purpose, we use this relative measure of skewness, which is gamma 1. And further, if gamma 1 is less than 0, then distribution is negatively skewed. So if gamma 1 is positive, then distribution is positively skewed. Further, if gamma 1 equals to 0, then we say that distribution is symmetric. In this way, we use these three coefficients of skewness depending on the data. Means if the data are quantitative, then we can use Karl Pearson's coefficient of skewness for by calculating mode and standard deviation. If the data are qualitative, then we have to use Bowley's coefficient of skewness, means we have to calculate the quartiles, and after that we calculate SB. If SB is less than 0, then we can say that the distribution is negatively skewed. If SB is greater than 0 or positive, then we say that distribution is positively skewed. If SB is equals to 0, then distribution is symmetric. Then the third measure of skewness, which is widely used, which is depending on the odd order central moments, is this. So Pearsonian's coefficient of skewness, and in this way we can say about the skewness of distribution. In next lecture we will study the kurtosis of frequency distribution. So thanks for watching.